Hello everyone, myself Sneha Murthy, studying in Sri Venkateshwara College of Engineering from ISC branch. Today we are going to discuss a subject is data structures and applications, and the topic is additional list operations, sparse matrix and doubly linked list. First is additional list operations. Here, introduction to additional list operations. Additional list operations provide more functionalities to manipulate and manage the data in the list. These operations extend the basic list functions, offering more flexibility and efficiency in handling the data structures. Types of additional list operations. Here, the first one is address of operator, and the second one is pointer difference variable. First is address of an operator. It returns the memory address of the variable, for example, and the variable returns the address of the variable. Second one is pointer difference operator. It allows the access to the value stored at the memory address pointed to by a pointer. For example, star pointer retrieves the value at the address stored in the pointer. So these are the two different types of the operators, that is address of operator and the pointer difference operator. And the next one is operators in C. Operators plus plus minus minus is a unary operator. Plus minus ampersand symbol modulo symbol it's a arithmetic operator. Greater than or equal to, lesser than or equal to, greater than, lesser than, these are the rational operators. And symbol and the modulus symbol is the logical operator. And symbol, modulus symbol, greater than, lesser than is the bitwise operator. Equals to, plus or equals, star equals, those are the assignment operators. And the question mark is a ternary operator or a conditional operator. These are the operators in C. Next one is linked list operations, that is traverse, insert and the delete. These are the various linked list operations that allows us to perform the different actions on the linked list. For example, the insertion operation adds a new element to the linked list. First one is traverser, access each element of a linked list, and the next one is insertion, adds a new element to the linked list, and the next one is deletion, it removes the existing elements, and next one is search, it's find the node in the linked list, and the sort, it sort the nodes of a linked list. So these are the 5 procedures we have to follow in the linked list operations. First, that is traverser, insertion, deletion, search and sort. Next is traverser linked list. Displaying the contents of a linked list, it's very simple. We keep moving the temp node to the next one and displaying its contents. When temp is null, we know that we have reached the end of the linked list, so we get out of the while loop. Here is a simple C programming example for a traversing linked list. Struct node star temp equals head, printf equals, we have to list the elements, while temp factorial is equals to null, printf %d temp minus greater than data, temp equals temp minus greater than next. The output of this program is 1, 2, 3. And the next one is insertion at the beginning. For the insertion, we have to allocate memory for a new node. We have to store the data, change next of the new node to the point to head, change head to point to the recently created node. Here is the example for a insertion at the beginning, that is struct node star new node equals malloc size of a struct node, new node minus greater than data equals 4, new node minus greater than next equals head equals new node. Next is insertion at the end. Allocate memory for a new node, we have to store the data, traverse to the last node, change next of the last node to the recently created node. Here is an example for a next one is deleting from the beginning. Point head to the second node. We have to point the head to the second node, that is head equals head minus greater than next. This is a simple example for a deleting from beginning. And the next one is deleting from the end. Traverse to the second last element, change its next pointer to the null. And a simple example is struct node start temp equals head, while temp minus greater than next minus greater than next factorial equals null. Temp equals temp minus greater than next, open the bracket, temp minus greater than next equals null. Then is searching of an element on a linked list. You can search an element on a linked list using a loop using the following steps. And the first step is we are finding item on a linked list. Make head as a current node. A loop until the current node is null because the last element points to the null in each iteration. We have to check if the key of the node is equal to the item. If the key matches the item, it returns true, otherwise it returns false. And the example is this, the searching of an element. We can see a simple C programming example. Next is sort element of a linked list. For sorting of an element, we can take a bubble sort example. The steps we have to follow in the sorting of an element is first we have to make the head as a current node and then create another node index for the latter use. If the head is null, return, else run a loop till the last node, that is null. In each iteration, follow the following steps, that is 5 to 6. Store the next node of current in index. Check if the data of the current node is greater than the next node. If it is greater, swap current and index. Check the article and bubble sort. Here is a bubble sort example for a sorting a linked list. Next is sparse matrix. Definition of a sparse matrix. Sparse matrix is a matrix that contains a few non-zero elements. Almost all the places are filled with zero. Matrix of m into n dimension refers to a two-dimensional array with m number of rows and n number of columns, and if the non-zero elements in the matrix are more than zero elements in the matrix, then it is called a sparse matrix. And in case the size of the matrix is big, a lot of space is wasted to represent such a small number of the non-zero elements. Similarly, for scanning, the same non-zero will take more time. The example for the sparse matrix is 4 into 4 matrix, that is 5 0 0 0 0 8 0 0 0 0 3 0 0 6 0 0. Next is syntax and the array representation. The two-dimensional array is converted into one-dimensional array with three columns representing row, column, value. Array representation. The two-dimensional array is converted to one-dimensional array with three columns representing a row, a column, and a value. A row index of a non-zero element, a column index of a non-zero element, value at the same row, column index in the 2D. This is a representation of a row, column, and value. And the next is linked list representation. In linked list representation, each node has four fields as given below. The first one is row index of the non-zero elements in the matrix, column index of the non-zero elements in the matrix, the next node reference to the next node, and the value represents the value of the non-zero elements at row, column position in the matrix. Here is the picture of that how the row, column, next node and the value are represented. Here is a simple 3 into 3 matrix for a sparse matrix, that is 1 1 0 0 0 2 and 0 0 0. In this matrix most of the elements are 0, so it is a sparse matrix. We have to conclude that in any of the given matrix it contains most of the 0 means then it is a sparse matrix. Next is advantages of using sparse matrix. There are four advantages, that is memory efficiency, computational efficiency, reduced storage requirements, improved performances, and bandwidth reduction. First is memory efficiency. Sparse matrix stores only non-zero elements, saving memory compared to the dense matrices. Where every element is stored, this is particularly advantageous when dealing with a large matrices with many zero values. The next is computation efficiency. Sparse matrix can lead to the more efficiency computations in a certain algorithms, especially when the majority of the matrix elements are zero. Operations involving sparse matrices often require fewer arithmetic operations leading to the faster computations. Next is reduced storage requirements. Sparse matrix requires less storage space, which is crucial when dealing with the large datasets or in situations where memory is limited. Improved performances. Many algorithms can take the advantages of a sparsity of the matrix to optimize their performances. Sparse matrix representation is very quicker traversal and manipulation of the data, leading to the faster execution of a sparse matrix. The next is bandwidth reduction. Sparse matrices often have a lower bandwidth reduction to the matrices. Next is disadvantages of using sparse matrix. The four disadvantages are complexity, memory overhead, algorithmic complexity, and limited hardware optimization. First one is complexity. Implementing operations on a sparse matrix can be more complex compared to the dense matrix, as you need to handle the irregular structures of a sparse data. Memory. Next one is memory overhead. Sparse matrices often require additional data structures to represent the non-zero elements and their positions. This can lead to increased memory overhead compared to the dense matrix. Next one is algorithmic complexity. Some algorithms that work efficiently with dense matrix may not perform as well with the sparse matrix. Sparse matrix algorithms often have different type complexities. Next one is limited hardware optimization. Sparse matrix operations matrix can easily optimize for a certain hardware architecture as a density. Next one is doubly linked list. A doubly linked list is a type of a linked list in which each node consists of three components. That is star previous data and the next previous one data and the next one. The previous one addresses of the previous node. Data means it's a data item and the next means address of the next node. Here is the representation of the previous data and the next. Next is representation of a doubly linked list. Here is an example that how we can represent a doubly linked list. That is 1, 2 and 3. And the next is insertion operation in doubly linked list. Following insertion operation can be performed on a doubly linked list. The first one is insertion at the beginning, insertion at the end, insertion in between of nodes. Doubly linked list insertion at the beginning, algorithm of insertion at the beginning. We have to create a new node, assign its data value, assign newly created nodes next PTR to the current head reference. So it points to the previous start node of the linked list address. Assign newly created nodes previous node to the null. Assign the current head's previous node to this new node. Change the head reference to the new node address. This is a representation of the insertion of the doubly linked list at the beginning. Next is doubly linked list insertion at the end. Algorithm of insertion at beginning. We have to create a new node, assign its data value, traversing till the end of the linked list, call this node num, assign newly created nodes next node to the null, assign newly created nodes previous node to the temp, assign temp's next node to this newly created node. This is the picture how we can insert the doubly linked list at the end. Next one is advantages and disadvantages of the doubly linked list. At first is advantages of using doubly linked list. First one is it saves time as we can traverse in both the direction. It utilizes memory as we can construct and delete nodes according to our needs. Insertion and deletion of the node become efficient if the position is given. Next is disadvantages of using doubly linked list. Uses more memory per node. Insertion and deletion takes more time because extra points are needed to be maintained. These are the advantages and disadvantages of doubly linked list. Thank you.